morning, everyone, and welcome to this new Wi-Fi 360 Prime interview. It's my pleasure to welcome Stellan Ohrn, President Icomera US. Hello, Stellan. How are you today?
Hi, hello, Edlan. How are you? Doing great, thank you.
Well, thanks for participating to this show. Very excited to have you. Why don't you tell us first who is Icomera?
Yes, so thank you for this opportunity, Edlan, again, and we're really pleased to work with you guys. So Icomera, we are about 15 years old. The company started in Sweden back in '99, but since 2002 we've been with live systems on buses and trains. So really we provide passenger Wi-Fi and a way for transportation authorities to take their onboard system back to an enterprise. But today we're going to focus on the Wi-Fi issues that you have in vehicles traveling at high speeds.
Yeah, what sort of customers do you have in the US?
Yeah, so in the US, I think we tend to focus on two major segments. On the road side, Greyhound is a great example. They're owned by First Group, a big international group. And then on the rail side, the one example we can use is in Silicon Valley, where they have a lot of intensive Wi-Fi users. We're on VTA, Valley Transit Authority, so we're focusing on all their light rail and buses in that area. And also we have our units installed on the Stanford buses up in Silicon Valley at the university there. So.
Excellent. So what general trends do you see in transportation?
Yeah, so before we get into the Wi-Fi specific things, I think it's important to understand what is driving our business niche. And we have seen a rise in the public transportation due to that a lot of people are moving into the urban areas. And this trend is just continuing to rise on a global basis. And that means that as a society, we have to solve this issue by increasing the public transportation and make it easier for people to travel by public transportation. And especially in the US, when you look on the East Coast and the West Coast, we see this happening as states are funding new projects. There's talk about even high-speed rail trains in the US, which is very, very good for our business. And then, of course, with the Internet of Things, there's just, so much demand for Wi-Fi and just devices talking to a Wi-Fi network, and that's where we come into play. So if you go to the next slide, what we have, if you look at a vehicle traveling at high speeds, either a bus or a car or a train, it's, the vehicle is made out of metal and it acts like a Faraday cage, and it's very hard to get a good signal inside a moving train or bus or moving vehicle. So the whole thing that we're trying to solve is how do you provide a reliable, high-speed Wi-Fi connection inside a vehicle traveling at high speed. So what we show in this slide is we have a very unique mobile router. We call it the X6 platform. So we can take any available IP data signal and then combine and aggregate this bandwidth. So in this slide, we're showing that, most commonly in the US, people tend to rely on to backhaul maybe Sprint, Verizon, AT&T, or T-Mobile. So you will use the cellular links. But in some cases, when you don't have coverage for marine applications, we will instead use a satellite feed and aggregate that bandwidth. There's also very common that transportation authorities have, or cities have some kind of Wi-Fi on the ground already. So we can also use the external Wi-Fi network and provide that signal and aggregate that capacity inside a vehicle. So that's what we're trying to show on this slide. And again, what's unique with us is that we have an opportunity to have 6 links inside the unit, and then we can aggregate that capacity. So for example, if you're an end user and if you're on a VPN connection, we monitor the different links. If the quality on one link goes down, we seamlessly move over that traffic to another link. So you as an end user, you will never lose your connection or have to reconnect your VPN connection.
Okay, this is fascinating, and I'm sure we can dive into a specific example here. Another, you have some experience in Europe, for example, with the Czech Railways Railways. Tell us about the experience there and the challenges and lessons learned.
Yeah, so as you understood in the earlier slide, the transportation authorities, they have to pay the backhaul cost. And so, for example, if they rely on cellular links, and if you give free Wi-Fi to your end users, the data buckets will, they will quickly run out, and people, the more bandwidth you give the end users, the more data they will use, right? So there's different techniques. You can either limit the bandwidth per user, you can give them a bucket of data, and then when they have used, let's say, 250 megabytes, then you throttle them down. But then, of course, the end user will be a little bit disappointed when the data speeds decrease. So instead, then, to have the end users surfing on the internet, there's a trend now to be able to save on the backhaul cost to keep the end users inside the vehicle. And there's different ways you can do that. So our unique box, the X6 again, has a virtual machine, and you can actually run virtual machines inside the unit, and so you can port applications. So in the Czech Railways case study here, what we did is we worked with a partner developing a infotainment solution. So the whole infotainment solution resides inside our mobile router, and then as you as an end user, when you log on and try to get to your Wi-Fi, you get this nice interface where you can watch movies, you can listen to ebooks, you can play games, and if you want to go out to the internet, you can also do that. But again, it reduces the number of end users that actually decide to surf on the internet because they have free content available, and you keep them inside the vehicle and thus saving on the backhaul cost.
Okay, so if I understand well, it's local content that's being paid for by advertisers, and in exchange, passengers get free Wi-Fi.
Exactly. And a good extra, or actually I guess benefit you get from this is that the transportation authorities can use this platform also for their onboard system. So in the background, we can also channel, if they have passenger counting systems, if they have camera systems, we can also channel that traffic and offset the backhaul cost.
Okay, excellent. So can you share with us your vision of the future in terms of what is a connected vehicle and where you see you guys providing value?
The trend we see today is that there's a lot of different equipment installed in vehicles could be passenger Wi-Fi, it could be a camera system, it could be checking for eco driving, how the drivers actually learn how to drive more efficient. So our play is, with our unit, we think we can take several of these systems, consolidate them, have the applications more as virtual machines running in our unit. And so as a transportation authority, you don't have to be able to buy different hardware, you don't have to support different hardware, support different interfaces, maintenance, and then instead we will work with partners to develop, and we already have, as you can see in this slide, a lot of different existing applications that our customers are using. So again, our vision is, fewer boxes, fewer hardware, fewer machines inside a vehicle, and then we will also be able to aggregate the capacity and get a very high bandwidth, very high throughput, even for Wi-Fi users. Excellent.
Well, this is fascinating, and I have many more questions, but for the sake of this interview, we'll limit it to that for today. So I want to thank you, Stellan, for sharing your vision and insights. I want to thank the audience for listening up, and I'll wait for the next Wi-Fi 365 interview. Thank you all.
Thanks very much, Adam. Thank you.